Objectivity. This video essay features quotes, readings, and information from Boyd and Crawford, the critical questions for big data, and discusses big data and its objectivity. Big data at its best strives to find patterns in the jumbled information and devise intelligent ways to categorize it. Over the internet, about 6.5 billion linked devices exchange data. This amount will climb to 20 billion by 2025. Big data studies the sea of data and attempts to convert it into information that revolutionizes our world. The scientific method attempts to remove itself from the subjective domain through the application of this passionate process whereby hypotheses are proposed and tested, eventually resulting in improvements in knowledge. Nonetheless, claims to objectivity are necessarily made by subjects and are based off of subjective observations and choices. Page 667. Basically, the concept of big data itself is subjective as it consists of information that is vast and raw. But the fact of the matter and the fact of big data is the concept of big data obstructs the nature of objectivity. When human researchers participate in choosing, analyzing, and deriving conclusions from data sets, subjectivity in big data analysis becomes apparent. Personal biases and viewpoints might impact interpretations, which will result in subjective consequences. Some people wrongly think that researchers who use numbers create facts, while those who tell stories don't. This belief keeps the old idea that science and social studies are very different in the conversation of big data. Big data might accidentally support these old ideas about what's true and what's not in social studies. In means of big data, objectivity means seeing things as they are, without any personal feelings or opinions getting in the way. Scientists aim to be objective by carefully conducting methods and experiments to discover facts about the world. However, since scientists are human, they can still be influenced by their own experiences and ideas. Even the choices of what to study can interpret results and can have huge effects on the results of data. Things like personal beliefs or outside pressures also impact this data. So while scientists try to be objective, it's impossible to recognize that complete objectivity, and it's hard to achieve humanely because humans are naturally subjective. These are crucial aspects of analyzing big data. Researchers work with data, but data isn't just plain facts, it's multifaceted. Vast and complex amounts of information cannot simply be managed with standard computing tools. Big data as a concept is complicated, and there's multiple different types of data. There's structured data, which is organized information, unstructured data like text, and even semi-structured data, which is partially organized. Because data is so complicated, researchers require special methodologies and cutting-edge technology to interpret and exploit it properly. A model may be mathematically sound, an experiment may seem valid, but as soon as researchers seek to understand what it means, the process of interpretation has begun. Page 667. What this means is big data needs to be understood and interpreted. Every field has its own rules for understanding data. Even scientists use computers to analyze social aspects as well. And social big data is a sort of data that is more subjected to subjection. They still have to figure out what data means, and the interpreting process starts the moment they look at the data. When scientists decide what to measure, like in social media data, they have to make choices. For instance, they have to decide to count certain things and ignore others. These choices aren't just facts, they involve researchers' judgment. An example of researchers' judgment is researchers categorizing social media posts into topics or themes. As you can see on my screen, Kanye is trending in politics when Kanye is a rap artist. He's known for entertainment. Things like this differentiate the subjectivity and objectivity of big data. Another example that we'll get into later is a student who worked for Twitter's algorithm and entered a contest in proving one of his prophecies, found that Twitter's algorithm is biased towards lighter, slimmer faced people, according to The Guardian. Whole lot of nothing. As a large mass of raw information, big data is not self-explanatory, and yet the specific methodologies for interpreting the data are open to all sorts of philosophical debate. Can the data represent an objective truth, or is any interpretation necessarily biased by some subjective filter or the way that the data is cleaned? Page 13, Boyd and Crawford. If a dataset has millions of pieces of information, it doesn't mean it's random or representative of the whole picture. Big data, despite being a lot of information, doesn't explain itself. It's not just about having a lot of data. The quality and reliability matter as well. A lot of data does not guarantee important conclusions. In order to extract usable information from big data, it must be interpreted, analyzed, and contextualized. It does not come in with built-in answers. Researchers have to use their knowledge to identify these patterns, interactions, and insights into data. The value of big data comes in the human-driven processes that make sense of data and extract important knowledge, rather than just having a large volume of information. When researchers use big data sets from the internet, mistakes and missing information often occur. The internet can go down or lose data, especially when combining different data sets. Data scientists have to be careful about the data that they collect, checking for any biases. An example of a bias through data is credit scoring. Credit scoring models and analyzing vast financial data inadvertently perpetuate biases against specific ethnic or socioeconomic groups, affecting loan approvals and interest rates. An example of this is in Black America. Racism is perpetuated through the credit score system, as well as racial biases have been shown to increase in racial disparities among African American and American Latino populations, with substantially lower scores than their white counterparts. Due to past biases in the data used to train these allegations, big data and credit card systems accidentally discriminate against Black and Latino people. These previous loan practices or financial choices reflect on these biases against these groups. And in the data, the issue of big data is that the algorithm can learn and perpetuate these biases moving forward. The machine is still built by man. Interpretation at the center of data analysis, regardless of the size of a data, it is subject to limitation and bias. Without those biases and limitations being understood and outlined, misinterpretation is the result. When researchers analyze big data, they often get tricked by biases in the computer programs they use. These programs learn from biased data that can make unfair predictions. Researchers unintentionally see what they want to see in data, ignoring things that don't fit in their beliefs. To avoid these problems, researchers need to carefully check their computer programs and make sure and be aware of their own biases. It's essential to consider different viewpoints and other perspectives. The primary problem with relying on big data is expecting to be completely objective when it's created by people with their own biases and viewpoints. Even though data is presented as facts and figures, the way it's collected, interpreted, and analyzed is influenced by subjective opinions and beliefs of those who gather it. This means that data, while extensive, still carries hidden biases and perspectives from its creators. Bogdan Kulinch A graduate student at EFPL University in Switzerland showcased algorithm biases during a competition at DEF CON Security Conference in Las Vegas. His demonstration revealed the presence of bias in the algorithm designed to highlight the most compelling parts of images in previews. In Coolidge's study, biases were demonstrated by creating artificially generated faces with diverse features. These synthetic faces were subjected to Twitter's cropping algorithm to observe which features the software prioritized. The findings revealed that the algorithm exhibited biases, emphasizing certain fair skin tones, contributing to an understanding of potential bias and technological facial recognition or image processing capabilities. Data is like exploring a huge sea of information, and it needs a thoughtful approach. The real value of data isn't just about having a lot of it, it's about the choices and views of the researchers. With that being said, big data doesn't tell us everything. It's how researchers interpret and make sure of the information that matters. Just having tons of data doesn't mean we automatically have important insights. Researchers have to be careful in understanding and analyzing and putting in data into context to get useful information. To analyze data correctly, it's crucial to know the limits and biases that come with it. The methods used and how researchers understand data are also very important. Even though scientists aim to be objective, it's important to recognize that there's subjectivity in the choices during the research. In simple terms, big data is the most valuable when researchers approach it with a scientific mindset and understand the limits of big data and the different stories it can hold.